I was listening to the song Drill Ye Terriers Drill as covered by the Chad Mitchell Trio as the Terrier song, and was wondering if I could figure out the wage that the subjects in the song were being paid.
Last week, a premature blast went off. A mile in the air went Big Jim Goff. And drill ye terriers drill, drill ye terriers drill. Well, it's worked all day for the sugar in your tea. Down behind the railway, and drill ye terriers drill. And blast and fire. When next payday came around, Jim Goff $1 short was found. When he asked what for, came this reply: "You've been back for the time you was up in the sky, and drill ye terriers drill."
The strategy in solving this problem would be to figure out how much time he was in the air, and from there determine the wage. Using this equation, we can solve by starting the object at rest at the top of the curve and letting it fall with an acceleration due to gravity down 5,280 feet. When this is solved, we get a time of 18.109 seconds, but this is only the amount of time for the downward leg. Once the up and down is accounted for, we get a time of 36.218 seconds, and that is the amount of time in the air. Given that this man would have been paid $1 for the time he was up in the air, which is 36 seconds, we get that he was paid $1 for every 36 seconds. But this does not compare to the way we normally think of wages in dollars per hour. We must multiply that number by 3,600 seconds for every 1 hour, which gives us a wage of $99.40, which is a pretty good wage for the late 19th century, which is the time period the song is set in. I do realize that rather than indicating high wages given, which would not have been the case, this song is trying to show the unsafe conditions the men worked in, and that when they did get injured, they were not paid. Now, it is clear in this song that the man who was blown up in the air survived, but how realistic is that? Ignoring any shrapnel, I'm going to just look at the speed and acceleration needed. This is where ignoring air resistance means that the speeds are actually much lower than they would need to be with air resistance. Using the equation V equals V initial plus acceleration multiplied by time, this gives us a max speed of 583.099 feet per second, almost 400 miles an hour. A survivable speed for you to meet air. And while I could use this equation to determine the acceleration needed to reach the speed calculated, if a uniform acceleration is assumed and the distance accelerated is set to 10 feet, an acceleration of over 500 times that of gravity is calculated. But it would probably be easier to compare it to something you can picture in real life. A car hitting a wall at that speed. Almost certainly not survivable. And that is why I don't listen to music while doing homework.